So for example 4, we're just going to do a really quick problem. We're just going to find the approximate values. Since we are online and I'm doing these recorded lectures, we're going to use the online program Desmos instead of using an actual handheld calculator, just so we all can see what's going on here. Okay. All right, so here we are on Desmos using the scientific calculator. We see here it looks like a generic calculator, but it's online instead. So we see we have some functions here. We have all of our numbers, operations, and whatnot. We see we have a button here. It says degrees and radians, so we want to make sure that we're in whichever format that we want. So because of our problem, we had two things that we wanted to find the approximate value of. So our first being tangent of 40 degrees. So we're going to put in tangent, and we already have our calculator in degrees. So when we type in 40, it's going to know that that means 40 degrees. We don't have to put in any extra symbols. So we have tangent of 40. And this gives us the value of 0.839099631. Because of our problem, we want to round to 2 decimal places, so in our case, we'll round up to a 0.84. So let's go ahead and pop back over to our notes and write that in. So we wanted to find the approximate values of tangent of 40 degrees. We use Desmos to say that this is going to be about 0.84. It didn't actually say rounded to decimal points, but I meant to write that in. We do want to round to 2 decimal points. So all right. Our next one is going to be cosecant of pi over 5. So let's go on back over to Desmos. So like we said earlier, if we want to do something like cosecant of pi over 5, remember we need to put this in the format that we would normally put it in. So we know that cosecant is 1 divided by sine. So we're going to write 1 over, and now we're going to have sine. And we can use our function here as well instead of typing it. Oops, sorry, that was not the right thing. We can plug that in using this function. So we have 1 over sine, and remember we're using pi over 5. So, whoops, sorry, pi is right here, so we say pi over 5. And if we see, our answer is, oh no, 91.19. That seems a lot wrong. And we realize that we are in degrees. We want to flip over to radians, and now we have an answer of 1.701301617, which seems a lot more accurate. So remember to do that. If you get an answer that looks crazy, try and see if you're in degrees or radians when you shouldn't be. So now we're in radians, now we're in the right format, and we got our answer of 1.70 round into 2 decimal places. So let's go ahead and pop back over to our notes now. And let's go ahead and write that. All right, so we used our calculator and we determined that this is going to be about 1.70. So these are our approximate values using our calculators. So if you do not have an on-hand calculator, I highly recommend Desmos. All right, and then our last objective here, objective 7, we want to use a circle of radius r to evaluate the trigonometric functions. So if we want to use our trigonometric functions on a circle with any given radius, then our 6 oh my gosh, I'm having the hardest time saying that today. Trigonometric functions will look like this. So we have this theorem here. Now we have to say that for any angle theta in standard position, we're going to let our point P be the point on the terminal side of theta that is also on the circle. X squared plus y squared is equal to r squared. Then sine of theta is now going to equal to y over r. Cosine of theta is going to be equal to x over r. Tangent of theta is going to be y over x, where x doesn't equal to 0. Cosine theta is going to be r over y, where y does not equal 0. Secant squared is going to be equal to r over x, where x is not equal to 0. And cotangent of theta is going to be equal to x over y, where y is not equal to 0. So for our problem here, we want to find the exact values of the 6 trigonometric functions of an angle theta if the point 4, -3 is a point on its terminal side in standard position. So looking here, we have drawn out our circle and we've plotted our point 4, -3. So because we have our points already, we want to use this point with our equation of a circle. So we want to use point P, which was 4, -3. We want to use the points in the equation of a circle. In order to find the value of r. So we wrote in the equation of the circle right there. But our equation of a circle is x squared plus y squared is equal to r squared. But we know that x in this case is 4. So we have 4 squared plus -3 squared is equal to r squared. 4 squared is going to be 16. -3 squared is going to be 9. 16 plus 9 is equal to 25, which is equal to r squared. So we'll take the square root of both sides to get that r is equal to 5. And normally we would say it's equal to the positive and negative versions of 5. Since we're thinking about a radius, it wouldn't make sense to have -5. So it has to be +5. Or we just write 5. So our radius is going to be +5. Now that we know our radius, we know our value of x, we know our value of y, and we know our value of r. So we can go ahead and use our theorem to determine the values of our 6 trigonometric functions. So starting with sine of theta is going to be y divided by r. So y in this case is -3 and r is 5. Then cosine of theta is x over r, where x is 4 divided by 5. Then tangent of theta is y divided by x, where y is -3 and x is 4. So we get -3 over 4. Then cosecant of theta is going to be r over y. So this is going to give us 5 over -3. So this is just -5/3. Secant of theta is going to be r over x. So r is 5, x is 4. So 5 over 4. And lastly, cotangent of theta is going to be x over y, where x is 4 and y is -3. So if we ever want to find the values of our 6 trigonometric functions when we don't know theta, but we know our point and we know our radius, this would be how we would find these values. All right, so that concludes up our lecture for section 6.2, and I will see you again in lecture 6.3.